Hello everybody, welcome back to the channel. Today I have a treat for you. I'm going to walk through processing the Atlas Comet. We will take you all the way through processing this and we will hopefully have a fantastic image from my raw capture. So let's get to it. Here we are in PixInsight, loading up Blink. I'll take a look at this comet. Modify the stretch. You can already see I took 10-second subs here, so you can already see we got a really well framed image, and I made just a guess on the rotation and the coordinates by looking at my Sky Safari app on my phone, and I just got lucky. I was very happy with the framing when the telescope locked it in right out of the gate. I am doing a fixed background capture here and letting the comet travel through. Flipping through these. Is anything terrible in here? I'm gonna run with it and see what we get. There's also a light as I get close to the bottom of the chute. Well, there's a really nice one. Okay, that one's gonna go. And I don't know if that's gonna, you can start seeing it here, I think. Yeah, I can see a little bit of it here. There it is. So you can see the reflection on the left side there. I don't know how well that's gonna come out of this. We'll see. Another band of reflection. So I'm gonna, oh, I don't like that. So I'm gonna run a couple rounds of this, and I may have to remove some of these banded frames, but I want to come back after doing that. There's another one. That was pretty bad. So is that one. Maybe I'll take those out. Now we're gonna move on. Set up my cosmetic correction template. Just drag that off. I normally have workflow icons in here. Here we are at WBPP. I've loaded a master dark. It's not exactly the right length, 15 seconds versus 10 for the photos, but I think it's gonna be fine. And then I am using dark flats. I normally don't use a master dark on my 2600 Pro, but this is the 1600. I do use it on the 1600. Then we got the flats for this, RGB, 10-second lights. Post calibration, we're gonna have 10 minutes of roughly of each channel. It'll get us a 30-minute exposure. I'm not gonna drizzle this. Everything else is set the way we want. I do need to set my output. Set GT81 master folder. We're all set. And we will run this. I check it real quick. Looks good. I did use a cosmetic correction template right here instead of the automatic. I know my settings that I like. I do use the automatic pedestal now. I do like that feature. And I did have to set my flats, match them to their darks. So we'll run this and we'll come back. Okay, registration's done. I did change my directory name and I had to go back and correct a few things to run this. So the next thing we want to do is align the comet, make what we'll call a comet registered set of subs. For this particular step, there is a comet alignment script. This is going to take all of the registered frames that we just made. Let me add them all. And we're going to set our output directory. Okay, I'm going to make a new folder. This is going to be the Comet registered. All be aligned to the Comet itself. And we're going to look at the file here. I'll do a quick STF on it. Get this very center of that comet. We're going to go to the last image. Same thing. Get the very center. And run it. All right, so we've completed. Next, let's go ahead and make our star background. And this will tell us about that reflection as well. All right, so we get the LRGB combination. Open these master lights. Take a peek at each one. We don't care about the comet. This is gonna be for the stars. Some trouble with these flats. That's not gonna be a problem though for the star background. We're gonna put these colors in where they go. And we'll go ahead and run that. We'll do a linked stretch, control down, hitting this. So that's gonna be our stars. Next thing we're gonna do is a crop. And we're gonna try to get rid of these artifacts on the edges, knowing that the comet was traveling down. So we're gonna take roughly this section out, and we're gonna save this for use later. Go ahead and apply that crop. And okay, that's fine. The next part we're going to do is a DBE on this. I'm actually going to use DBE instead of one of the paid or newer processes. I still find DBE does a better job, especially for strange or unique structures. So we'll select this. I'll do 15, generate, take a look at it, and change your tolerance 2.5, regenerate. Just want to take all these off of the comet itself. All right, so correction to subtraction. I'm going to go ahead and replace target. It's already normalized, so we don't need to do that. Okay, there we go. Get that cleaned up. All right, so our next process is going to be SPCC. Make a preview. Doesn't need to be very big at all. Just drag that on there, get your preview. Back to our image. All right, here we are. A nice straight star graph there. We're done with SPCC. Now we're going to run Star Exterminator, generating star image only. Go ahead and run that. Okay, so that kicked out. We don't need this image. This will be our star background. Now at this point, the stretch that we have is really good coming out of Star Exterminator. Let's rename this Stars. What I like to do is use a technique that I think Sasha Weiss I learned from. I'm not sure. I think he learned it from somebody else on his View into Space channel, where this is a really stretched, ideally almost, so you can tweak it later with curves. We'll use the STF and the histogram. What we're going to do is we're going to take star tab, drag it to the string transfer function. That loads it with the view we need. And we're going to drag this over, triangle over to the histogram transformation with the preview on and track changes. And then we got to turn off the stretch up here, screen transfer function. So now you can see that we have the stars that we talked about. We'll clean up this little bit of mess right here with the comments, leaving a little bit of residue. But right there is an ideal stretch, and we can close the preview. We can drag the triangle onto the stars. Now these are stretched. So I'm going to put this aside for a moment. We're going to focus on this background here. I'm going to clean this little bit of mess up. We're going to use clone stamp. Clone stamp. I'm just going to hold down Control, click an area, make this brush a little bit bigger, and just going to wipe out all these places where I don't want stuff, and not to replicate any stars. Don't matter too much. Do another spot here. Get all that stuff out of there. And one more spot right in there. And execute. And we're done with clone stamp. And there's our star background for starters. Put that aside. So the next step is going to be to remove the stars from all of the Comet registered frames. And I'm going to use a process that I learned from Adam Block, and he had two versions of this. He had the original working with Russell Croman with Star Exterminator, which is the process we're going to use, Star Exterminator batch process. That combined with a mask. So we are going to hit process batch here in a second. So we're going to open one of our example Comet images, just in Comet registered. We'll just take one of the first ones here, Comet aligned one. I'm going to stretch it so I can see it better. We're going to zoom into the comet itself. We're looking at this bright structure because, as if anybody here has done this process with Star Exterminator, it'll tend to pull out part of the comet when you run this process. So we're going to make a mask to protect that area. The way we're going to do that is by running the game script. We're going to do a binary mask, and we're going to zoom into the same area here, and we're going to add, put an STF on this so we can see it, add this protection area for the mask. Going to be pretty generous with this. We want to cover the entire area outside of here. We don't have any accidental glow removal. Then we're going to run this, make a mask. We're done with the game script. If we back out here, the next thing we want to do is run convolution on this. And I'm just going to run a couple rounds of low level to get that buzzed out. And then we also want to invert this. So you hit Control I because we want the protection to be over this comet area. Then I'm going to change the name of this. Let's call it Comet Mask. And we can minimize this so it's ready to be used. Now we're done with this picture. Now we have everything we need to run a batch on this. So we'll hit process batch. We don't need to turn on anything else here. I'm going to set our output. Come back in here. We got the Comet registered. We're going to make a new folder and we're going to call it Starless Comet. Inside here, select that folder. Oh, you could invert the mask here. We're not going to do that since we already inverted it. And then we're going to select Comet Mask, select input files. And these are the Comet registered folder we had before. So select all of those. It doesn't matter which filter. And then it's just asking we want to do that. We're going to say OK. And it's going to make all of these new Starless with mask protected area. And that's going to leave some artifacts that will remove via an integration process. Depending on how many frames you have, this is going to take a very long time, especially if you have a slower computer. Mine's mid-speed, so I'm probably going to let this run for quite a while and then come back to it. And it might be hard to tell progress on this. One of the ways you can do it is go to the folder where the script is making the files, and like I have 182 of these to do, and there's 10 of them done right now, so I could check the status here, which is what I do. All right, so the 182 frames completed. Took quite a bit of time. So the next thing we're going to do is take a look at the frames. Apply the STF. Preview the area around the comet. See, there's a star right there. You'll see there's a few stars. There's a couple stars. That's all we got. So the comet's protected, but those stars hanging around. Everything's looking good. Everything else is clean. So now we're going to do image integration. Because there's shifting of those stars between frames on each filter, it will reject those if we make an aggressive pixel rejection routine. So we're going to add all of the red first. Filter R. Okay, then for this, we don't want to care about weights, pixel rejection. I'll just do Windsor's normal. Rejection 2, here's where the magic is. We're going to make this sigma high aggressive, and then we're going to run it. we look at this pixel high, you can see those stars that were in the protected area are being rejected out. Low, there's really not much to see here. And the magic is, look at that. No stars, and because we protected it with the mask, we didn't lose any of the comet in the star exterminator step that normally will grab hold of part of this. Nice clean comet. I'll save this. I'll run the same thing for the other two filters. All right, so now we have all three channels. They're looking really clean, looking fantastic. Next thing we're going to do is linear fit to line the color channels. Some people say not to do this with red, green, blue, but I have had success with it. So it's going to require linear fit. Before we can run linear fit, I need to know which channel's got the lowest mean. Require statistics. So if I look at the channels, this mean, this is the first one, B, RGB. B is 2676, G 1932. So far G is the lowest, R 1262. So red is the lowest mean. Therefore, and I already have it loaded, but you load it into here, then open the other two channels and apply to each channel. And I probably should have cropped all of these images before I started this whole process. It's kind of a mistake if I go back and do that. Now we're done with linear fit. I can restretch these, minimize, restretch, minimize. We need to combine these. I like using LRGB. You can use color combination. Same thing. Actually use pixel math if you want. Their first view of the color image. Just name this RGB. Alright, this is me from the future going back in time to remind everybody at this point we would want to use this crop icon from the star background, and we would just double click that and it'll apply on the same area for this to match up for this comet. I did not do this for the rest of the video. I actually used this outer border, which is a mistake, but we will apply it here so you can see what it looks like. And then that will match up when we merge the stars in. Now, when I did it with Pixel Math later, it ended up looking fine because it just stretched it a little bit. So I'll actually go back and redo the entire image to be matched up properly and cropped like this. So now we're at the point where it's pretty much color to taste. All right, now it's time to do the stretch. I'll mostly use curves, but I want to do partial stretch on this. Pretty good. Apply it. That's going to be our starting stretch. And time to make a lightness mask. And we're going to stretch this as well. About there. Apply it. Reset. Now it's stretched. Another detail in there of that. Back to the RGB. Apply it as a mask. We're going to protect the comet first. Reset this. Preview. Darken that background a little bit. Actually, reset that. Get curves out. Preview. Background's down in this first quadrant. Darken it down. More here. Keep the comet on. Okay, like that. Apply it. Reset. And invert the protection, so now the comet isn't protected. Apply some. I like green comets. I'm making this green. Horrors up here. All in this middle section. So if we take the bottom down, do a little bit, apply that. It's going to do another round. There's another. I like that too. Bring it up a little bit for the middle areas of the comet and the tail. Preview. Yes, I like that much better. Apply it. Oh boy, I really like that. Getting pretty bright though. So let's reset, or let's pull this off as a curve configuration for this. Reset, go to saturation. Check saturation first. What we got here? Check the preview. I don't like that as much. Turn off the mask for a second. Put the mask off. Alright, so you can keep playing with this until you get the color the way you want. Stop there for the moment. Call this Starless. So next thing we need is pixel math, and we're going to need single expression formula everybody uses to recombine their stars. And I'll create an RGB image. You have to have at least one of them open. Stars are up here. I'm going to combine. There is the image. And I'd like to have had a brighter tail. I could make this tail brighter if I worked on it more, but for this demonstration, I just wanted to show how this works. You can see the stars coming through there. and all the colors of the stars are intact. That is how I process comets, other than playing with color more and the lightness masks. Drag that off as a backup copy. Alright, so the next step I like to do is take this luminance, go into the toolbox, and get a combined images script. And I'm going to use the Starless, and we're going to use the RGB luminance, and we're going to do a blend of 30, well, that looks about right, and a little vibrance into the first image. Starless image. Get the green into bottom. Now we get the, I'm bringing that tail out farther. And I'm going to make that into a new image. The tail extended a little bit more. Just combine the luminance back in there. So now we have that. I get pixel math out, and I have the standard formula everyone used to blend stars back in. So this is going to be our Starless, and we're going to, we got a RGB color space, create a new image, run that. So this is our two options I had. So obviously we can play with colors even more. When load curves, reset, preview. Actually, I'm going to put the mask on here again, versus, so I'm protecting mostly the comet. And we're going to darken the whole background with histogram here, or after, just to slightly apply that. That again. Remove the mask. Now I'm going to crop this a little tighter. Make this more about the strong parts of the comet I have. I would have normally cropped this earlier in the segment, but didn't do that, so I'm going to do it now. Pick something like that. Now I have a much brighter area in the back. I'm going to try something else. Range selection. Screening on. Preview. Okay, so the difference here, because it's like a lightness mask. Background protected again. So I want a little bit different color here. So that yellowish green, I want more of a pure cosmic green, I'll call it. And this comet's normally white. I'll end up publishing it white. I just think the green will come out better on this demonstration. That's quite a nice change there. Accept that. I really like that second round of it. Let's do it again. Even like that, but not quite as much. We'll go with that right there. close that out. Remove the mask. Now, I messed with the stars when I did that. That modified the stars a little bit. So ideally you want to do what I just did, the color, before you add the stars in. One last step I like to make on here, just a really mild application of noise exterminator. You can use other programs for denoising. If you look in here, you see there's some grain. And I already ran it, so we can see it takes that out without affecting the rest of it. It just smooths it out. So this is the final image, and I like green comets, so I made it green. You could color this to taste, but the point of this video was to show how to go through the process of getting everything aligned and not messing up the core with the star removal with the special masking technique. So I'll probably do some more work on this to get the tail more exposed, maybe tone down the green a little bit, get some more definition. But that's all I got. Till next time, clear skies, take care.